Hello, in this short lecture I'm going to talk about the notion of arc length. This is part 1. I will make 2 more videos. In this video I will talk about the notion of arc length in Cartesian form. In the second part I will talk about the notion of arc length if the formula of the function is given in parametric form. And in the last video I will talk about again the notion of arc length if the function is given in the polar system, in the polar coordinate system. Okay, and this video is produced on the demand of a follower who requested me to introduce this concept as a video. So this is the theorem that I want you to know. Let f be a differentiable function defined on the interval from a to b with a continuous derivative. The length L of the graph of f over the interval from a to b is given by this formula. Integral from a to b is square root of 1 plus f prime of x squared dx. Okay, what does the formula mean? Consider that you have a coordinate system and this is the graph of your function y equals to f of x, and you want to restrict yourself on the x-axis between a and b. Okay, and then of course I am interested only in this part of the graph of my function, and I want to calculate the length of this reddish part of the curve. What do I mean by the length? Let us imagine that you have a piece of a string that you can exactly bend it in a way that it completely overlaps with this part of the graph. Okay? And then you stretch it, make it completely taut, and then take your ruler and measure the length of that taut string. That is what we will call the arc length. Okay, and we denote it by L. According to this theorem, if I want to calculate that L, I have to calculate the integral of this integrand, 1 plus f prime of x squared dx, in which x goes from a to b. Yes, so this will give me the arc length. Okay? Of course, what does it mean that the function is differentiable and its derivative is continuous? It means that the function is very well behaved. Sometimes if we say that the function is differentiable and its derivative is continuous, these two words can be combined and saying that the function is smooth. Yes? What does it mean? It means that the function is a continuous curve. It means that you can draw the graph of the function with one pen stroke, and it means that the function does not have any sharp points in it. Okay? So for example, the graph of the function is not like this. Let me draw it like this. For example, if this is your coordinate system, and let us say this point is point A, and this point is point B, and this is the graph of the function y equals to f of x. If I want to find this length, I'm not allowed to use this formula, because you see that between a and b, the derivative of the function is not continuous because I have a sharp point there. Of course, it doesn't mean that I cannot calculate the arc length in this scenario, but I have to break this to two curves. Okay? So I have to calculate the integral from a to c, and then calculate it from c to b, and then add them up. Okay? But if I want to use this formula, the function should be differentiable. The curve should be continuous without sharp points. Okay, so now let us try to solve one example. Find the length of the graph of the function f of x equals to 2/3 x to the power of 3/2 on the interval from 0 to 8. Okay, so let me write a formula. And I have to calculate f prime first. Yes, so f of x is equal to 2/3 x to the power of 3 halves, then it means that f prime of x, 3 over 2 goes down, will be simplified by 2/3, so it becomes just 1, x to the power of 3 halves minus 1, which becomes 1/2. But this can also be written as a square root of x. Okay, so the L becomes equal to the integral. Here, the lower limit is 0, the upper limit is 8, so I go from 0 to 8, then square root of. So this square root that you see here is this square root, and then I have 1 plus f prime to the power of 2. So it becomes 1 plus f prime is the square root of x to the power of 2 dx. So this becomes integral from 0 to 8, square root of 1 plus x dx. But that is very simple, so I have to calculate a primitive function for a square root of 1 plus x, which is of course x1 plus x to the power of 3 halves divided by 3 halves, which becomes 2/3, but then I have to run it from 0 to 8. So then it becomes 2/3. If I replace x with 8, it becomes 8 plus 1, 9 to the power of 3 halves, minus 2/3. If I replace x with 0, it becomes 1 to the power of 3 halves. But 9 to the power of 3 halves can be written as 3 to power 2 to the power of 3 halves, so it becomes 3 to the power of 3, which is 27. Yes? So then it becomes equal to 2/3 times 27 minus 2/3 times 1. So this becomes 18 minus 2/3. So this becomes 52 over 3 length units. So that is the answer to this problem. Okay, now let us also test using GeoGebra app. It's a free app. I want to test what we have done. So I would start typing if, and then from this menu I choose this condition. So the condition is that x is less than or equal to between 0 and 8. Yes. And then comma, and the function y is equal to 2/3, and then I have x to the power of 3 over 2. And that is the function that you see here. So let me make this window a little bit smaller. So this is the graph, and of course because 8 is beyond, so let me squeeze the y-axis a little bit. Okay, and then move this to the other side. Yes, now we have it here. So I go now here, I open this menu, and then I have this function inspector. And then when this menu is this one is chosen from this menu, I click on the function, and you get a lot of information regarding this curve. But as you see now, the limit is between this number and that number. So let me try to type 0 there, and then 8 here, and then press enter. And then you see that the length is now calculated. So let me, I don't know why my computer is a little bit slow now, but anyway. So this is the arc length that we calculated, the length of this bold red line. And according to a function inspector in GeoGebra, the length is 17.333. And of course, that is exactly the number we got. Do you remember? I got number 52 over 3, and that is exactly 17.3. So this app is free, so that's also good to understand things better by visualizing them. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.